All right, we've got a lesson here on optimization problems. Now, in these types of questions, you're going to be given scenarios and you want to either maximize something or minimize something. Could be like maximizing the volume or the area of something, or we might want to minimize costs, something like that. So if we think about the work that we've been doing with derivatives, that's one of the applications of derivatives. We can find maximums and minimums by finding critical numbers and things like that. So just keep that in mind as we work through this one problem. Here we go. So let's just say we have the following situation. A manufacturer wants to design an open box having a square base and a surface area of 108 square inches. What dimensions will produce a box with the maximum volume? Okay, so that's what we're trying to do there. So always on these questions, you just ask yourself, all right, what am I trying to maximize? What am I trying to minimize? In this case, it's going to be the volume. And as far as getting a visual here, well, we know a couple things. We know the box is going to have a square base, which is why we can say that's x by x, and then it's got a height. And if you notice it too in the question, we're looking for it to be an open box. All right, so we're not covering up this whole thing. That is going to be an open box up top. And they do give us information about the surface area being 108 square inches. All right, let's see how this is going to work. And all right, so first of all, we're going to start off with the kind of what we call our primary function here. And since we want to maximize volume, that's going to be where we start. All right, so the volume of this box now, remember how volume works is we essentially find the area of the base, so we can multiply these x's together. So it's the area of the base, which is x squared, and then times the height. Okay, so we can call that x squared h. Okay, now that is what we want to maximize as the volume. So we'll need to find the derivative of that formula. However, what we can see here is that we have two variables. We got an x squared and an h. So because of this, we need to get whatever it is we're maximizing or minimizing, we've got to get it in terms of one variable. So now we'll use the other information that we have, which is the surface area, okay? And we'll kind of do this over here. So the surface area we were given as 108 inches. Let's think about how we can find the surface area now. That's just going to be the face of each of these, the area of each face added up, but keep in mind it's going to be an open top, okay? So what we can do now is, all right, if we look to here, the bottom, we already know that's, all right, so the bottom face there is going to be x squared. And usually in a box, we would say it's going to be 2x squared for the top and the bottom. However, if it's an open top, it's just going to be that one base of x squared. Then, if we look at each of these faces, that's going to be x times h. That's how we'll get the area of each one of those, okay? So it's going to be x times h, and since we have 4 of them, we can multiply that by 4, okay? So the surface area is x squared plus 4xh. Well, we were also given the surface area, which is 108 square inches. And that's going to be x squared plus 4xh. And then if we look back up here, again, we want to get this all in terms of one variable. And right now what we want to do is essentially replace this h with something in terms of x, and that way the whole volume formula will be in terms of x. Okay, so that's where we want to get the h alone. So we can subtract x squared from each side first. So we'll get 108 minus x squared equals 4xh. Okay, we'll keep going now. To get the x, to get the h alone, we will divide each side by 4x. So h will equal 108 minus x squared over 4x. Okay, so now that we have h in terms of x, I can replace this for h. And there we go. So looking back up here, we're now going to rewrite this volume formula as x squared times, instead of h, we will do 108 minus x squared all over 4x, okay? So that's our new volume formula. And we'll see if we can clean this up a little bit. And I'm seeing here that we have, x squared here and 4x down below. So we can just say this is now x to the first power and then just get rid of that x, okay? And then clean it up a little bit more. So we can distribute that x up top. So that's going to be 108x minus x to the third power all over 4, and which then we could just rewrite this as 1/4. Okay? You don't absolutely have to do that, but I think it's going to make it a little bit easier to deal with. So this is now our volume formula, and we're trying to maximize the volume formula. So we can find the derivative and then set it equal to 0. So here we go. Derivative then, what we can do is we can kind of leave out this 1/4 right now, and then take the derivative of what's inside. So that is going to be 108 minus 3x squared. Okay. Now we can distribute this 1/4 through there. So that's going to be 1/4 times the 108. Turns out that's going to be 27. And then 1/4 times the -3. We can just call that -3/4 x squared. And that's our derivative. And we want to set that equal to 0 to find our critical values. Okay. All right, getting the x alone now, we can subtract 27 from both sides. So we have -27 equals -3/4x squared. Change up the color here just so you can see exactly what's happening. So now to get the x squared alone, let's multiply both sides by the reciprocal. So we're going to go -4/3 on both sides. Okay, that's going to leave us with x squared on the right. And then if we multiply all this together, we can do some cross canceling. Essentially, it ends up coming down to 36. Okay, so which means that x is going to be equal to 6 and -6. So those would be our critical values. But keep in mind here, we are talking about the dimensions of a box. So therefore, this -6 will not help us, but the 6 will. Okay, so looking back at this box now, we now know that this is going to be a 6 inches by 6 inches base. In terms of finding the height now, that's the one thing we need to do. Well, we could go back to here and plug in our 6 to figure out what our height is going to be. So let's go ahead and do that. So we'll say 108 minus 6 squared all over 4 times 6 equals h. Okay, which leaves us with 108 minus 36 all over 24 equals h. And when you do your subtraction and division, we will end up with h equaling 3. Okay, and so what that tells us now is that the dimensions of this box that are going to create the largest volume will have a height of 3 inches. So there we go. So our dimensions then are going to be 6 inches by 6 inches by 3 inches, and that will be the dimensions that give us 108 inches squared for our surface area and for the maximum volume of this box. Okay, so that's just a quick introduction to how optimization problems work, and we'll get some more practice on that in class. And if you have any questions at the point, you can let me know. All right, thanks.